Now we're looking at naming molecular compounds. Molecular compounds, remember, are those molecules that are covalently bonded. So we've just finished doing a lot on ionic bonding. Molecular compound is actually much more simple, and it has to do with really the prefixes, and it has to do with the fact that the nonmetal atoms in covalent bonds can combine in more than one way. When we're talking about ionic bonds, sodium fluoride, for instance, is just one thing. It can only be NaCl. Whereas if you have a nitrogen and oxygen can combine in a myriad of ways. It's not just NO. It can be NO, NO2, N2O, NO3. So what we have to do with covalently bonded molecules, we need to use prefixes. So it's important that we know these prefixes. And it's I know it seems like another thing to memorize, but I think a lot of you guys know these anyway. We all know what mono is. Mono is one. Mano y mano, when you're up against maybe a senior who says, "Yo, let's meet in the hallway." You go mano y mano, one-on-one. Di, two, like you ride a bicycle. Bicycle has two wheels. People call it bicycles. Well, it's also a dicycle, two wheels. A tricycle, tri is three, triangle. Tetra, four. Penta, like a pentagon, five. Hexa, six. Hexagon is six-sided. Hepta might be probably the hardest one of here to remember, as hepta is seven. Octa, octopus, eight. Nona, like some people call their grandma Nana, or Nana, or like if you have 9 grandmas, or Nana, 9, just remember the N. Deca, 10. Decade. So these, you do really know what these are anyway. Again, hepta is probably the hardest one to remember. So let's look at some rules for writing binary molecular compounds. Binary is 2. So you want to confirm, first of all, that it is a molecular compound and it is binary. Is it made of 2 nonmetals? So look on your periodic table. Look if it's a nonmetal, and look if it's binary of 2 elements. Then name the elements in the order listed in the formula. So if it says CO, you would list the carbon first, then the oxygen. Use prefixes to indicate the number of each kind of atom. If you have C2O, you're going to say dicarbon monoxide or dicarbon monoxide. You do not use mono when the formula contains only one atom of the first element. So for instance, CO2 we know as carbon dioxide because of the 2. We don't name it monocarbon dioxide. There's no point in it. It's just redundant. So if the first, and it's a given that if the first element is 1, you don't have to put the mono in front of it. But for the second one, you do. So this is carbon monoxide. And then really that's it. Covalent compounds, molecular compounds are really pretty simple to name. They're hard to put together, but they're much more simple to name than the ionic. So let's try some here. NO2. We have nitrogen. We don't need the mono. And 2 oxygen. Dioxide. And look at the ending again. It ends with IDE, just like the ionic. Now this one's different. This is dinitro. Dinitrogen. Monoxide. We do have to put the monoxide there. Monoxide. This one is, as we went over, carbon dioxide. And we talked about carbon mono, 1 monoxide carbon. Now there's 4 chlorines. So remember that in the ionic, the chlorine is chloride, and there's 4 of them, so it's tetra. Carbon tetrachloride. P2O5, it's 2, so it's diphosphorus. 5 is pentaoxide. S2F10, disulfur decafluoride. Now let's try going back the other way and putting formulas to the name. Silicon disulfide. This is easy. We don't even have to think about charge. That's why these are actually quite easy. Silicon Si disulfide. There we go. We don't have to combine charges and amounts. It tells us with covalence and molecular. Carbon, we just did that. I don't know why I listed that again. Carbon tetrafluoride. Nitrogen disulfide, 2 sulfurs. Phosphorus pentachloride. Phosphorus chloride penta, 5. Dinitrogen, that's dinitrogen, and 2 pentaoxide. And phosphorus, we got a tri in there. Phosphorus. So phosphorus trihydride is pH3. And we're just going to look a little bit at naming acids and bases. We're not going to go too much into this, but just some rules that you'll see. And now you'll see this, and you'll wonder why maybe something is named one thing or the other. Bases, first let's just get bases out of the way. Bases are really the same thing as any other ionic compound. There's no real special rule for that. For instance, a base NaOH, sodium hydroxide. There's nothing really special about bases as far as naming them. Now acids, though, you'll see different things. Naming and writing formulas for acids and bases, we're not going to spend too much time on this. Just it is important because we will see some things like HCl, hydrogen chloride, but it's also hydrochloric acid. And acid is really anything that will produce hydrogen ions, or also called a proton in solution or water. So that means that something that is leading with an H is usually an acid. Let's look at the rules here, also on table 9.5, page 292. If we have something that ends in IDE, the anion that ends in IDE, like most of the other anions, and that has hydrogen in front of it, for example, HCl, we would normally call this hydrogen chloride, ends in ide. What we do is we put hydro in front of it, and the stem, which is chlor, and then put ic. So it would be hydrochloric acid. We put an acid there to show that it is an acid. Let's try another one. So if you have HF, it normally would be hydrogen fluoride. Well, that's a fluoride. So we're just going to say hydrofluoric, the stem, acid, hydrofluoric acid. Or HBr, that's hydrobromic acid, hydrobromic acid instead of hydrogen bromide. The hydrogen makes it the acid. SO3 2 minus. And let's look at the ite ending, ITE. Remember that's polyatomic. SO3 2 minus. We have the stem of sulfur, for instance, would be us. And sulfurous acid. If you have H2SO3, it would be sulfurous acid. If we had NO2, that's a that was nitrite, excuse me. And as the acid, you would see HNO2, nitrous acid. The ion is an ite, sulfite, nitrite. With the acid, it becomes sulfurous acid. This becomes nitrous acid. Now let's look at the ate ending. So if you start off with the NO3 minus, that's a nitrate. That means we're going to change that ate to an ic. So it's going to be nitric acid. HNO3 is nitric acid compared with HNO2, which is nitrous acid. SO4 2 minus is sulfate. But if it's an acid, if we have an H in front of it, H2SO4, we're going to use the stem of sulfuric acid. So this is sulfuric acid, H2SO4.